For question 7, we want to use the randomization output given here to answer the question, do small dogs live longer than large dogs? In class, when we looked at the randomization test, we were trying to determine if the students on one exam had a harder exam than the other. However, students from both exams were claiming this. So when we looked at the output, we looked at both values added together for the p-value. However, now we only want to know if small dogs live longer than large dogs, which means we don't care about the smaller end down here. We only care about this upper end up here. So when we subtract, we want the larger numbers to be involved. Now what we can see from this is that if we are above 1.4667, which was the original difference that they found in the average for the large dogs and small dogs, we can see that we end up getting a p-value of 0.009. This is a small p-value. Remember, with small p-values, what this means is that the null hypothesis is likely not true. Now, with the null hypothesis, we are claiming that the difference should be 0 between the two groups, or that there's no difference between the two groups. But because we get a very, very small p-value with this, that means that there's a very small chance that this is actually true. So because it's a small p-value, there is sufficient evidence to suggest small dogs live longer than large dogs. And again, the reason for this is because our original claim was that there is no difference between small dogs and large dogs. But because of the small p-value, we're assuming then that this statement that we made before about there being no difference is incorrect, which means that our alternate hypothesis, meaning that there's small dogs living longer than large dogs, should be true.